So let's look into the concept of DEVS coupled model. DEVS coupled model is the aggregation of your model, right? However, it does not distinguish atomic or coupled model. Either can be coupled. That's the key. This is being called closed under coupling, all right? So if X and Y exist, then and it follows DEVS model formalism, whether either being atomic or coupled, it can be coupled. That's the basic idea of the DEVS coupled model and closed under coupling property. So here, closed, what's the meaning closed? Closed means that it is being in the set. If there is a model set of DEVS model set, after the coupling, that will fall into the DEVS model as well. So DEVS model can be coupled, and the coupled model will be what? DEVS model. So that's the property of the DEVS closed under coupling. Anyhow, coupling will require a set of models to be integrated. And so that to integrate, X and Y should be the input and output should be interacting with each other. For example, let's say we have model 1, which takes X output and X input and Y output. And let's say model 2, X1, Y1, X2, and Y2. If these two are going to be coupled, there should be a mapping relation between Y1 and X2. Okay? So Y1 output will be taken into X2's input as an input. If we want to create a feedback loop, then Y2 will be linked to X1, and there should be a mapping relation between Y2 and X1. Okay? So to do that, first thing that you need is you need to set up input and output. And then you need a specification of these mappings. Models output and to models input. Models output to input, right? Right. And also, there are other type models output to the coupled models output. So if the M1 and M2 are being coupled together, then there should be some source, right? X1 source and Y2 going out, right? Right. So these coupled models input, coupled models output exist. So here we are specifying models output to coupled models output. Models output to coupled models output. Models output to coupled models output. Then coupled models input to models input. Coupled models input to models input. So there are these three specific mappings of these inputs and outputs. Finally, there is one more function to specify in DEVS coupled model, which is a select function, which we are not going to discuss in the scope of this course. And this specifies how to resolve time conflict in between the inputs. When does take the which input will take the precedence in terms of the processing, and that is being handled by the select function, which will be outside of our course. So anyhow, we need to specify integrated models and the inputs and outputs and their relations. That is being needed. And after that, DEVS model coupled, and this becomes DEVS model closed on the coupling, DEVS model, closed on the coupling will create AB. And AB and C can be DEVS model, and can be coupled, and ABC. And ABC will become the most outside model. And here in the DEVS community, it will be called outmost model. Okay, outmost model. So that's the structure of DEVS coupled model in concept. Let's look into the details. So let's look into the formalism of the DEVS coupled model. So DEVS coupled model has how many sets? Variables x, y, and m variables. A set. Okay, x is a set of input events, y is a set of output events. Right. And here I want to notice that I want to make specific. X is being specified for this coupled model. For the coupled model, not the model itself, right? So model has its own inside xy, and this xy here is for the CM, coupled model. And external input coupling, external output coupling, internal coupling, 3 mappings exist. And these mappings are actually being a set, not as a function. We are going to look into that later and select that we are going to, I'm just telling you that it exists for the tie breaking of the input event. At the same time, 2 input events occurs, which one takes the precedent determined by the select, but I'm not going to discuss this in detail. Here, as I explained, x, y, inputs and outputs, pretty standard. And we want to have M or component models at this layer, at this definition of layer. Okay. So here, for example, if AB and C is being coupled, then AB and C are going to be the elements of M. EIC is external input coupling, and external input coupling means that external input is coming in, and that is being coupled with model's input, right? So that's the EIC. External output coupling is what? External output coupling is output is being combined with being paired with what? Model's output, right? So that's the EIC and EOC. IC is what? IC is inside model's output is being coupled with what? Input. The input here. External model, internal models, right? Integrated models, output event is being coupled, is being mapped with inside also integrated models input. So that's the internal coupling. Here, EIC, EOC, IC are not being functioned, but as what? As an element of this possible combination set. Okay? This possible combination set defines, okay, so this element is being mapped to that element, this element is being mapped to the other element, so that it is not in a function format. But rather, as like saying a certain input xi is being mapped to what? Is being mapped to A's input is being mapped to, it's difficult to specify like this. I want to say A, B's like xi is being mapped like this. So to the coupled of AB, input exists, and input xi, CM's xi is being mapped to what? A's xi. Similarly, B's yj is being mapped to AB's yj. B's output is being mapped to AB as an AB's output. And here, that will specify what? B's output is being mapped to A's input, like this. B's output is being mapped to A's input, like that. Okay? Right. Like this. And then here, let's say this is a coupled model of the soldiers. Let's imagine we have soldier model and outputs are being specified like this, and inputs are being specified like this. So taking in and going out. Okay? So we have many of the input coupling, internal coupling, and external input coupling will be coming in and like this, external input coupling. And if it takes out, if we generated output going out, that is external output coupling. That creates two soldier model to be coupled to make a platoon. Of course, it's not going to be two persons team. The platoon means. However, let's just say two people will create one platoon, and two soldiers will create another platoon, and we have two platoons, and they are linked to each other to create a combat model.